Hello, hello.
Yes, sir.
Okay, let's start. So we are doing this Haloalkenes, Haloarenes. We
Yes,
have
sir.
started two class before. So what we have done in last class, we have discussed about the classification like 1 degree, 2 degree, 3 degree alkyl lights, types of alkyl lights based on the CX bond, the alkyl and the halide, the bond between the alkyl and the halide, based on the carbon having the hybridization sp3 or sp2. We have discussed that, and then allylic, benzylic, arylic, these type of halides are there. Then after we will discuss one method of preparation, which is this from the alcohol. Here, in this reaction, there is an intermediate state, which is important. Based on the stability of this intermediate state, the reaction will proceed. Okay, so we are discussing about the your discussing about the rearrangement in the last class. So the question is that rearrangement. So the question is that why we do rearrangement. Do you know about this? Why we do this stuff rearrangement? Do you know anything?
Sir, because we are combining the structures together.
No, we do not combining these structures. There is a purpose behind this rearrangement because, like, from alcohol, like for example, I am having this. Just give me one second now. So, like, I'm having this compound, and this is the alcohol. And if I react this alcohol with HCl in presence of ZnCl2, what will happen? First step is the protonation. My Cl will see HCl will break down into H plus and Cl minus, and this H plus will attack to this lone pairs, which is there on the oxygen. This step is known as my protonation. And after the protonation, what will happen? This thing will form. And this is a very good living group. Living group means that which leaves from this compound. Okay, so this will
Yes.
leave. Why? Because oxygen is very electronegative. So in order to achieve this stability, this will happens, and what will form? This carbocation will form. So here in this carbocation, this is the RDS, which is the rate determining step. This step will determine the rate of this whole chemical reaction. So why it is important? Because in this step, there is a thing which is known as rearrangement will happen. Why? Because to achieve stability, to achieve stability. In order to achieve the stability, we do the rearrangement, and there are different types of rearrangement. Like for example, we in this class we gonna discuss about the different type of rearrangement. The first one will be a hydride shift that you will see here in this example. What is this hydride shift? So see here, I'm having this cation, and you know that this is one carbon, this is another carbon, and this is 3 degree carbon. So three bonds are there, but the other bond which did not you are in you didn't able to see that this valency is filled by this hydrogen. Okay, so this hydrogen will go to this cation, this hydrogen with your two electrons, which will be the hydride. This hydride will shift to this positive position, cationic position, and this will form here. This positive sign will comes up here, and here the H will be attached. So this will form, and this is now 3 degree carbocation. Carbocation. So how did I know that this is stable? So in your class 11th, again there is a thing which is required from class 11th, which is your hyperconjugation. There's a thing which is known as hyperconjugation. Have you heard about this hyperconjugation?
Yes, sir. Yes, sir. We have heard about it.
What is this hyperconjugation?
Sir, I think it speaks about the like
It speaks about,
it alpha and like
yeah, alpha H.
yes, sir.
Okay, so what is this alpha H? What is this hyperconjugation? Why we count this alpha H? What is the requirement? Purpose.
Sir, because it is like interaction in the organic chemistry where electrons of sigma bonds are there.
Okay, fine. You're correct, but I need the purpose. So the purpose behind this is that if my alpha H will be more, then we can say that this compound will be more stable. Why?
Yes.
Because if my alpha H will be more, that means my transferable H will be more. So if my transferable H will be more, that means that the compound is more stable. So if we see here, let us count the alpha H in this 2-degree carbocation. Why it is 2-degree carbocation? Because the positive charge is present on that carbon, which is having a degree of 2. Like this carbon is attached with these two carbon, the 1 degree and the other one is 3 degree. So if you count the alpha H here, what you will see here. So here, this is the position. This is the you can say that this is the cationic position. So the carbon which is directly attached to this will be this carbon and this carbon. So the both the carbons are the alpha carbons. So here you can also see that there are three alpha carbons are here. This is the first alpha carbon, this is the second alpha carbon, this is the third alpha carbon. Why? Because this cationic carbon is basically directly connected to other three carbons, which is alpha carbons. Fine. So
Yes, sir.
the question is that these three alpha carbons having the alpha H. So we need to count those alpha H. So here I am having 3 alpha H. I am having 3H. And here also I am having 3H. And here I am having 2H. Why? Because the other two LNCs are already filled with the other carbons. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So here 8 alpha H are here. 8 alpha H are present here. Now let us count the alpha H here. So I am having 2 alpha carbons. Now this alpha carbon, this 3-degree alpha carbon having only 1 alpha H because the other 3 valencies are filled with the other carbons. And here I'm having 3 alpha H again because this carbon is 1-degree carbon and the other and the one valency which is filled with the other carbon. So 1, 2, 3, 4. Here also 4 alpha H is here. So if you see that before doing the hydride shift, my alpha carbon will be 4. But after doing the hydride shift, I'm having the alpha carbon of 8. So the increment in the alpha carbon, you can see that. So here, this means that the stability will increase. The stability
Yes,
stability
sir.
increases. So if my stability increases, then my reaction will proceed and my Cl minus now attacked to this position and I will get this compound. Fine, got
Yes,
it?
sir.
So this is the first type of rearrangement. The other one is my methyl shift. Methyl shift. Now discuss about this methyl shift. So I'm having an example of this methyl shift. Why? Because see here, this is my compound. Fine. This is my
Yes.
compound. So see here in this, I am having the cationic carbon, which is 1 degree. Here, this is the cationic carbon, which is 1 degree. So if I count the alpha H here, how many alpha H is there? Can you tell me, Hadia, how many alpha H are here?
Sir, over here.
Huh?
So 4 alphas are there.
Why? Can you tell me where are this 4 alpha H carbons are?
No, sir. 2 alpha and 2 beta.
2 alpha and 2 beta. Okay. So tell me where is the alpha carbon?
Sir, CH3 and then no, no,
CH3
sir.
there.
Like this straight.
Huh?
Sir, if you go straight, we'll get 2 alpha
Yeah.
and
So
two
this is
sigma.
only one alpha. This is the alpha carbon. Fine. So can you tell me how many alpha H are here?
Sir, 0.
0. Alpha H is 0 because the
Sir,
other this carbon is alpha carbon and this carbon having the valency which is filled by methyl groups, like this is the methyl group, this is the methyl group, this is the methyl group, and this is also the cationic group. So all these valencies are filled other than the alpha carbon, alpha
so, sir,
hydrogen.
So
So
this single C we will consider it as alpha H?
where is the single C?
Like the single C over here where we
This
are.
this is not the alpha H. This is
Yes,
just
sir.
the alpha carbon. This is the alpha carbon. The alpha carbon having the H which is attached to it, those hydrogens are known as the alpha hydrogens if it is present. If it is not, then we can't say this is alpha hydrogen. Like in this case, you will see here, this is the 2-degree cation here, 2-degree cation, and this 2-degree cation is directly attached to this and this carbon, this and this. So I am having two alpha H, and these alpha H having the hydrogens like this. So 1, 2, 3, 4. In total, I am having 4 alpha H. Alpha H is different, alpha C is different, alpha carbon is different, alpha hydrogen is different. Alpha carbon is that carbon which is directly attached to the functional group. Or or you can say that alpha hydrogen is that hydrogen which is attached to which is attached to the alpha carbon. So the hydrogen which is attached to the alpha carbon is the alpha hydrogen. Are you getting my point?
Yes, sir.
So this is what. Now what I need to do, I can see that here I can make this compound stable by doing the methyl shift. How methyl shift? Like if you shift this methyl group, if you shift this methyl group to this position, what will happen? Let's see. So my CH3 minus, this will gonna shift. Okay. So what will left if the two electrons will go with will be gone with this CH3 with the methyl, then it will be the positive sign which will come up here. Fine.
Yes,
And this
sir.
is the same CH3 and this is the same CH3. Now this is my CH2. Fine, this is my CH2 having the positive sign, but this positive sign is filled with this negative sign, and this negative lone pair. This is basically the lone pair because this carbon, this lone pair, this electron and this electron will go on with this CH3, and this is the lone pair which is going to be deposited in this orbital. This is the vacant orbital, no? This is the vacant p orbital here. If you see, this is the carbon having the three p orbitals. Like what is the electron configuration? 1s2, 2s2, and 2p. What? 2p2. So if you see here,
2p2.
this is 2s2. So this is the 2s group, 2s orbital, and in this orbital, the two electrons are completely filled, and in this 2p orbital, in this 2p shell, you can say that in 2p subshell, 1 and 2 electrons are here. So if you see that if I am having the positive sign, that means that this electron will be gone. If this electron will be gone, then we can say that here is the vacant p orbital is present. Here is the vacant p. Vacant means there is no electron is present. That's why it is vacant p orbital. So easily these two electrons will be accepted by this carbon. Okay. So this will be your CH3. Fine. This will be your
Yes.
CH3.
Yes, sir.
Anna, got it? CH3 or
Yes, sir.
something else? It will never be CH3. Why? Because it will be CH2 and this is CH3 that will comes up here like this. I'm not adding the hydrogen. If I'll do the hydride shift, then this will happen. But for the hydride shift, I need the hydrogen. But hydrogen is not there. That's why we did this methyl shift. Are you getting my point? So if we do
Yes,
this
sir.
methyl shift, this methyl will gonna comes up here in this position. Let us mark this position as 1 and this position as 2. So from the second position, my methyl is shifted to the first position like this. Getting my point?
Yes, sir.
So now let us count the alpha H here. So this is the functional group carbon, cationic group, and from this carbon, the direct carbons which is attached will be this one, and this one. These are the direct carbons which are attached. So these are the alpha carbons. So Hadia, can you tell me how many alpha hydrogens are here?
Sir, um, sir, 5.
Five? Are you sure? Hadia, sorry,
Sir,
Tayyab. Is she correct?
8.
How many?
8.
Eight. Yes, eight alpha hydrogens are here. Hadia, are you able to understand this? Because this is three
Yes,
carbon.
sir.
This is sorry, this is three hydrogen. This is three hydrogen. This will
Yes,
be
sir.
two hydrogen, which is directly attached to the alpha carbons. So these are the
Yes,
alpha hydrogens because this hydrogen is attached to that carbon, which is the alpha carbon. So that's why it is
yes,
alpha
sir.
hydrogen, and the count will be 8. Simple. Fine. Can I move forward?
Yes, sir.
So this is my methyl shift. Fine. So now the other one. So if you will be given with this compound like this. So this is your problem. So in this is a special problem because in this case you can see that clearly, like this is the alpha carbon. Fine. And this alpha carbon having this hydrogen. So this is the alpha hydrogen. Fine. And this carbon also having the
Yes.
methyl group. So what you will do? You will do the methyl shift or the hydride shift. What you will do? Hadia, what you will do? You will would you prefer the hydride shift or the methyl shift?
The hydrile shift. No, sir. Methyl shift would work here.
Methyl shift
Would work here.
would work here. So Tayyaba, are you Tayyaba?
Yes, sir.
Okay. And Hadia, what about you?
Yes. Sir, hydrile shift will work
Okay.
here.
So is this time Hadia is correct. We'll do the hydride shift. Why? Because we are concerned with the alpha H, the count of alpha H. Because as the alpha H will be more, the stability will be more. We need more transferable H. Transferable H means that the H which can shift from one position to the other position. This is the hydride shift. So so we'll do both the things. Like we'll do both the things. So Hadia told me that we'll do hydride shift. So let us count the number of alpha H after doing the hydride shift, and let us count the alpha H after doing the methyl shift. We'll do both and we see what will happen. So this is the first position. This is the second position. From the second position, I'll do the hydride shift. So what will happen? The positive sign will comes up to the second position, and this will be CH3 and this will be CH3. Fine. Now we'll do the
Yes, sir.
methyl shift as the Tayyaba said. So if we do the methyl shift, the methyl which is present at the second carbon at the second position will gonna be at the first position, and the positive sign will comes up here and the hydrogen will be here. So Tayyaba, can you count the alpha H in both the cases? First,
Sir,
first,
alpha.
first go Hadia. Hadia, how many alpha H are here in this case? Case one.
Sir, only.
How
Sir,
many?
nine. Nine.
Nine. Fine. Tayyaba, how many alpha H are here in this case? Your case two?
Sir, nine. Sir, nine alpha H are they here?
In which case? One or two?
Oh, so in the first case, it's like nine.
Okay. In the second case?
So in the second case, nine.
How? Can you count all these alpha H?
So we will not count H, single H.
No, because this is not the alpha H. Alpha H is that hydrogen which is attached to the alpha carbon. This is not the alpha carbon. This is the main carbon. This is the
Okay, sir.
you can say that this is the functional group carbon. So the directly attached carbons are these two carbons are the directly attached carbons. So the
So
alpha
sir, eight
hydrogen.
are there.
How many?
Eight alpha carbons are there
Why eight?
total.
This carbon is directly attached only to two carbons. So the alpha carbon will be 2. So if the alpha carbon will be 2, then 3 plus 2 will be 5. My alpha hydrogen will be 5. Be
Yes, sir.
careful.
Okay, sir. So sir, we will see only those alpha, right, which are attached to the carbon, like
Directly attached to the main carbon. So see,
yes,
if
sir.
you see here, this is my main carbon. This is the cationic carbon. From this cationic carbon, this H, sorry, this carbon, and this carbon. All these carbons are directly attached. If you see here, if you see this cationic group, this carbon will be directly attached carbon. Only one carbon is directly attached carbon. In this case, three carbons are directly attached carbons. In this case, only two carbons are directly attached. In this case, only three carbons are directly attached. So these are the alpha carbons. And what about beta carbon? So the beta carbon is the carbon which is present at next to the alpha carbon. So this is the beta carbon. You are also counting the carbon of beta, but this is not the
Yes,
case.
sir.
Just you need to count the alpha hydrogens, alpha carbon hydrogens. Getting my point?
Yes, sir.
So can you tell me which will be more in number? 9 will be more in number. So what is most preferable to do? Is it hydride shift or is it methyl shift?
The hydride shift.
Yes. So the answer will be the hydride shift. So Tayyaba was correct. Hadia was correct that hydride shift will be more preferable to do in order to achieve the stability. Fine.
Yes, sir.
Okay. So the next thing will be your ring expansion. The next thing will be your ring expansion.
Yes, sir.
So this is another thing of another way of rearrangement, ring expansion. What
Yes,
is
sir.
ring expansion? So this is also a type of rearrangement in order to achieve the stability. How? There is a ring, like we are having a ring of minimum, my ring will start from 3. Like minimum ring will be this, na? The closed structure is my ring. So the minimum ring is composed of minimum of 3 carbon. If minimum of 3 carbon is there, then I can form my ring. And if 2 carbon is there, then I couldn't form the ring, because if I am having 2 carbon, these 2 carbons are directly attached with it. The ring will never gonna be formed. So the minimum, the smallest ring will be 3, then 4, 5, 6, 7, 8. Okay. So what we'll do? So if I'm having like this, if I'm having the ring like this, I'm having 4 carbons which is attached like this. This is my cation, which is there, and this is my ring. If you see that 1, 2, 3 carbons are here. How many carbons? 3 carbons are present in the ring, and the carbon which is present outside the ring is my cationic carbon. So I should I do the ring expansion or should I don't? So in this case, what will happen? In this case, what will happen? I am having 3 carbons who are having the p orbitals, who are having vacant p orbitals. So can you tell me what are orbitals? So orbitals, I'm taking you from the basic. So the orbitals are those places where the probability of finding electrons will be maximum, will be maximum. Fine. So this is the orbital. How many types of orbitals are there? S, P, D, F. And the G is also there, but these are the subshells. Basically, these are the subshells. So this subshell, S subshell, having only one orbital, which is S orbital, and the shape of this S orbital will be spherical. And I am having p orbital. I am having p subshell. In this p subshell, I am having 3 subshell. I am having 3 orbitals. This will be px, py, and pz that I have explained you in last class. I am having d orbital. So in this in this d subshell, I am having 5 orbitals. 1, 2, 3, 4, 5. How many? 5 orbitals. And the name will be dx square, y square, d z square, d x y d y z y z d zx. So this is my orbitals, and there is f orbital like this: 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So in f subshell, I am having 7. I am having 7 orbitals. How many orbitals? 7 orbitals in f subshell. F subshell is you
Sir,
can. Huh?
sir, like, is it from according to the textbook? Because, sir, I think we don't have ring expansion.
You do not having ring expansion. Okay, fine.
Yes,
Fine.
sir.
Okay, okay, okay.
Sir, are you going according to the textbook? Because
Yeah,
there
yeah,
are
okay,
some
okay.
topics omitted from our, like, deleted.
Okay, so I'm following the NCRT now, so I think I'm having the NCRT which is you know the NCRT which is
Previous one.
the yeah, the previous NCRT.
So
So
you
that's why.
can go like on the net. NCERT textbook.
I'm leaving this topic because thanks for telling telling me. I do not aware of this. Sorry for that. So we'll move on. Okay. Okay. So if you are having just this like this will be there in your methyl shift and hydride shift is will be there in your textbook for confirm, because this is the basic thing that you should know when you'll do the method of preparation from your alcohol to the LD, alcohol to the alkyl halide. So this is the thing which will be there. This will never gonna be deleted out because this reaction is there in your textbook, and this reaction, this is the example which is there. So this will be there, and this thing will be there about the rearrangement of the hydride shift and the methyl shift, and we are leaving this thing which is your ring expansion. So sorry for that. So we are moving forward.
Okay,
Okay.
sir.
So the question is, I'm giving you the question. Okay.
Okay, sir.
So okay, the question is the order of reactivity, the order of reactivity of following alcohols with halogens. Halogen acid कह सकते हैं. Halogen acid. So the question is this. So I'm giving you the options. The options are, the first one will be CH3, CH2, CH2OH, and the second will be your CH3, CH2, CH, CH3, OH, and the third one will be your CH3, CH2, CH3, CH3OH. So these are the three compounds, and you have to tell me that if I react with the halogen acid. So what is this halogen acid? Can you tell me? The halogen acid is this. Like these are the halogen acid, like HX. HX is my halogen acid. Here X is my halogen, and acid is those thing which releases the H plus ion. है ना? So this is the acid. So halogen acid is HX, and it will be HCl, HF, HBr, HI. So these are the example of the halogen acids. Okay, so this is my halogen acid. So if I react these compounds with the halogen acid, what is the order of my reaction? Like which reaction will be more faster? Whether it will be, if I react this halogen acid with C, B, or A, which will be more faster? Can you tell me?
The
Fast
one faster will be
will be
B. Option B.
option
Option
B.
B.
Okay. हादिया और तैयबा.
Sir, Tayyiba.
Tayyaba. Okay, so the Tayyaba told me that key option will be fine. Hadia,
Yes, sir.
what about you?
Sir, wait.
Hmm.
Sir, wait. Um, so it will be C.
C. Okay. Confirm.
Yes, sir.
So the answer will be C. Why? Because this carbon is 1, 2, 3. 3-degree carbon. And if what I have told you, that if I react this this is the alcohol. First see, this is the alcohol. OH group is attached. So if it is the alcohol, and if I react with this halogen acid, what will happen? There is a thing which will be formed in the mid of the reaction, which is the intermediate state, and the intermediate state will be carbocation. Carbocation. So you need to answer me according to the stability of the carbocation. So which carbocation will be more stable? 3-degree carbocation will be more stable. Why? Just make this thing. CH3, CH2, CH3, CH3, and this is the positive sign. Why? Because if I add the hydrogen here, this will form here, and this is the leaving group. Best O plus H2. This is the leaving group. This will leave, and this thing will form. So this is the 3-degree carbocation, and they like 3, 2, and 3. How many alpha H is here? How many alpha is 3 or 3, 6, and 7, 8. 8 alpha H is here. If you see
Yes, sir.
here the positive sign will form, and 2 and 3, 5 alpha hydrogens are here. And if you see here, only if the positive sign will comes up here after leaving this thing, then what will be the alpha H? How many alpha H? Only 2 alpha H is here. So if you see the count of the alpha H, the C option will be the most appropriate option for the reaction to take place. So the order will be
Yes, sir.
C, then B, and then A. Fine?
Yes, sir.
Got it? Okay.
Yes.
Okay. So the next one will be my Lucas test. Okay. So now there is a thing which is known as Lucas test. So what does this test mean? Test means that if I'm having an alcohol, if I'm having an alcohol, like I'm having a sample, and I do not know that in that sample whether my alcohol is 1 degree, 2 degree, or 3 degree. How can I know that? Because it is a sample. There is nothing which is written over here. So if I know that this is a sample of alcohol, but I need to know that whether it would be a 1 degree alcohol, 2 degree alcohol, or 3 degree alcohol. How can I know this? So this is the test. We'll do this test, Lucas test, and after performing this test, we observe something, and on the basis of the observation, we're gonna tell that this is the 1 degree alcohol, or the 2 degree alcohol, or the 3 degree alcohol. So this is the Lucas test. So why we use this Lucas test? In order to know in order to know the degree.
Sir?
Yes,
Sir, actually, we don't have this topic in our textbook.
you are following NCRT.
Yes, sir.
So in the NCRT, this is the thing, Lucas test. By name, it might be a chances that by name it is not written, but this thing is definitely here because I'll tell you what is this. Just give me 2 minutes, I'll tell you why. Okay, just 2 minutes.
Okay, sir.
I'll explain this topic, then I'll tell you where it is there. Okay,
Yes.
so I need to know about the degree of the alcohol, because this will be the most asked question in this chapter. And the question will be from here. So if I need to know about the degree of the halogen, how can I do this? So this test will perform. Why? Because if I am having the alcohol which is ROH, and if I react, what is the reagent here? This is my reactant. This is my reactant.
Yes,
Okay.
sir.
If I react this reactant with the the reagent will be HXZnCl2. So have you remember this reagent? This is the reagent that we study before, from the alcohol to the alkyl halide. Getting my point?
Yes,
This
sir.
we have done here. This is the thing. This is the thing that we are discussing from the last class. This is the reaction. See, fine. So
Yes,
this
yes,
will
sir.
be the same thing. This will be the same thing. This is the same thing. But we are studying under another topic, which is the Lucas test. Why? Because this reagent also tells us that this is the 1 degree or 2 degree or the 3 degree, based on the speed of the reaction. That if the reaction will takes place in a faster rate, then it would be definitely 3 degree alcohol. If it took time like 1 to 2 or 3, 4, 5 minutes, then, or like 5 to 10 minutes, then it would be 2 degree alcohol. Or if it is 1 degree alcohol, the reaction will never gonna takes place. So on the basis of the reaction takes place or not, or the rate of the reaction, like if the reaction will just done in just 1 to 2 seconds, then it would definitely be 3 degree alcohol. And if it will take like some minutes, like 5 to 10 minutes, it would be 2 degree alcohol. Or if it doesn't takes place, that means the alcohol will be 1 degree. So I getting my point. Just basis
Yes,
on
sir.
the basis of the rate of the reaction, this is the test. So by name in your NCRT, it might be a chances that it will not be there, But definitely this thing will be there because I think I'm having the NCRT with me. So yeah, I am having the NCRT. So okay, in that NCRT, I'll tell you on which page it will be here. So just give me 1 minute. I will tell you. Okay. So this thing will be in part two, no? NCRT part two.
Yes, sir, part two.
Okay, just 1 minute. Yeah, I'm having NCRT part two like this. Okay. So in open this alcohol ether sorry halogen haloalkenes and haloarenes and which page method of preparation where the method of preparation is there and from alcohol. So if you see that from the alcohol, if you read this paragraph from the alcohol, the method of preparation, you'll definitely got the time of the reaction. Okay, if you read this like
Okay. So
so
from alcohol,
if you see here, if you see that in your in the method of preparation, page number 294, page number 294, according to my NCRT. Okay, so where the method of preparation of haloalkanes is there, and from the alcohol, and in that para, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Huh. So on 12th line, there is a thing which is written that the order of reactivity of alcohol with given halo acid as a halo acid will be 3 degree, 2 degree, 1 degree. So here the order of reactivity is there on the basis of the alcohol that it will be the 3 degree or the 2 degree or the 1 degree. So this test is there to test that the reaction will takes place or not on the basis of it. So if you go down in the next para, you'll see that the alcoholic solution, if you are having the 1 degree alcohol, then you need to heat this thing. You need to provide the temperature to proceed this reaction if you are having the 1 degree alcohol in order to complete this. So are you getting my point?
yes, sir, but there is no such line over here.
It is a deep concept. Okay. Okay. I think I'll see the new NCRT, then I'll tell you because I'm having my NCRT. In that NCRT, there is the thing which is 3 degree, 2 degree, 1 degree rate of reaction is
Yes,
there.
sir.
And the rate of reaction is directly this thing, like this. Why? Because if you see that if you are having 3 degree alcohol, then if you are having 3 degree alcohol, then it will be your fastest reaction. And a high turbidity. High turbidity means your
Yes, sir.
jhag. If you see the jhag. So this is the turbidity. So you will see the turbidity. And if you are having this 2 degree, then it will take some minutes. It is important thing. It might be chances that this will gonna ask because it is important. So I'll explain you. So it's very simple thing because this reaction is the same that I have explained you. This is the extra. If you see, this is the very simple thing. Just connect this on the basis of the rate of reactivity. Okay. So we'll move forward.
Yes, sir.
Okay. So this is the thing. So the next reaction will be I'll give you the question on this if I am having. Yeah. Okay. So yes, so there is a question. From the question, I'll explain you the another topic. The question is from reaction. I'll solve this question for you, okay? Because I need to tell you one more topic on this.
Okay, sir.
So C2H5OH plus HX will give your Z and X2 the same thing, and C2H5 X will be formed. So this is the general reaction of this thing. Okay. So the decreasing order of reactivity, decreasing order of reactivity of halogen acids. Okay. So this question is on the basis of, like, I need to know about the reactivity order of the halogen acid. Like I'm having the halogen acid as HX. Okay. So HX will be HCl or HBr or HI. So which will be the most uh, you know which reaction will be more faster rate, will perform in a most faster rate. So which will be the one, whether it would be HCl or HBr or HI? So the answer will be your HI will be the fastest one, then HBr, and then your HCl. Why? Because the size of my anion I will be larger. Like if you see if you see the periodic table, if you see your periodic table like this is your periodic table, something like this. है ना? There are some groups are here. This is your periodic table. Fine. So in that periodic table, if you
Yes,
see the
sir.
halogen which is there in your 17th group, there is a series of halogen like this. Okay. So
Yes, sir.
in that series in 17th group, this will be fluorine, chlorine, bromine, iodine is there. So if you go down the group in the periodic table, you also have learned this before, that if you go down in the group, what will happen? The size will increase. The size will increase. It's a general trend. Atomic size will increase. So if the size will increase, that means that the hydrogen is having a lesser size because it is an cation. Cation is generally having the lesser in size, and I minus will be an anion which is having larger in size. So I will having the highest size in its group. So if you compare the size order, the I minus will be the will having the maximum size, then Br, then Cl. So if you see that the bond will be easily breakable between H and I, because I is very larger and hydrogen is very smaller, so it will be very easy to break this bond. So as fast as this bond will break, the reaction will proceed, because the first step will be the protonation. So as fast
Yes, sir.
as the protonation will takes place, the reaction will be faster. Fine. And
Yes, sir.
this thing will be there in your NCRT. You can read that. Okay. And I can tell you one thing, that in organic chemistry, the organic chemistry is basically do not having a particular order. Like most of the teacher will different teachers having a different style of teaching the organic chemistry, because if you see the physical chemistry or the inorganic chemistry, there is an order that can be followed. But in the organic chemistry, there are certain chapters which are interconnected or interrelated with each other. Like if you see the hydrocarbon, and this is the chapter which is there in your class 11. But if you do not know the things of the hydrocarbon, you are not able to understand the concept of this haloalkenes and the haloarenes, because most of
Yes, sir.
these reactions are covered in that chapter. So there are some teachers who are having a style of teaching that most of the things they will cover in the initial chapters, and the things which are left they will cover in the later on the chapters. So if something which is there in the next chapter, if some concepts are going to be used in the particular or the current chapter which is moving on, they basically teach those topics in the current flow. Like this, if you see here, the test is Lucas test. But if you go to the second chapter of the organic chemistry of your class 12, there is a chapter which is known as alcohol, ether, and phenol. So in that chapter, you will
Yes.
also learn about the alcohols, and in that chapter you will see this reaction again. This reaction will gonna come again, just by just on the basis of this name, the alcohol. Because if you learn about the alcohol, everything related to the alcohol is gonna be there in that chapter, and this thing you already learned in this chapter as the method of preparation. But in the next chapter, this thing will come under the chemical properties, because this is the alcohol chemical property. Like alcohol, alcohol shows this nature if I react with the halogen acid. So it is the nature of the alcohol. Like if it is 3 degree, the reaction will be faster. If it is 2 degree, the reaction will be slower. This is the nature of the alcohol.
Yes, sir.
And this nature is the chemical property of that alcohol. So this thing will gonna come in the second chapter in the chemical properties of the alcohol, if we are discussing about the chemical properties. But if you see in this chapter, this alcohol will comes under the method of preparation of the alkyl halide. Like if I am preparing the alkyl halide, this is the way of preparing the alkyl halide. So this is the method of preparation of the alkyl halide and simultaneously the chemical property of the alcohol. So this is more lean towards the chemical property, and the thing that I have explained you before, this is more lean towards the method of preparation of the alkyl halide. So organic chemistry is basically mixed up, and most of the teacher having different teachers having different style of teaching. Like most of the teacher used to teach the things which is there at that position, but most of the teacher will prefer that the most of the things will come at the initial stages, so that if you go deep into the if you move on to the next chapters, the things might gonna be very easy for you to understand. Like very simple things are there. If this reaction will comes up in the next chapter, I'll just move forward, just telling you this. I have explained you in the last chapter. I'm moving forward. So this is the thing. Okay, so this is the thing which is there. Now I am moving forward to the next topic, which is my another reaction, which is your another method of preparation from my method of preparation from the alcohol. Same from the alcohol, but this time without rearrangement, without
Rearrange.
arrangement, without rearrangement. So
Yes,
here
sir.
this thing is very important, without rearrangement. And before, what I have done with the rearrangement. So why? Because the reagent is different. I used the reagent as my halogen acid previously, but this time the reagent will be different, but the reaction will be the same. Like my alkyl halide is going to be prepared from the alcohol. So see, if you see here, ROH, my alcohol. If I react this ROH with SOCl2, SOCl2, which is my thiocyanide. You can say that it is your thionyl chloride. Thionyl chloride. Yes. Thionyl chloride. Chloride. This is your thionyl chloride. If I perform this reaction, what will happen? Just my Cl will gonna be substituted here. My OH will be a substitute from my Cl. Understood? So this is the reaction without the rearrangement. Just do simple. Like this is the question. If I
Yes, sir.
react, if I if I do this, like this, Hadia.
Yes, sir.
Can you tell me the answer of the lower one? The if I react this with HCl and ZnCl2, what will be my answer? Be the my answer.
Sir, it
In
will
second
be
case,
HX.
where the HCl, no, it's not X because I have given you Cl. So can you tell me where the Cl will be going to be attached? Like
Sir, in
this is
the
my
third.
first, second, third, fourth. I am having four positions. Can you tell me at which position my CL will attach in the second case
Sir,
like
in
this?
fourth position.
In
Fourth position.
fourth position. Why?
Sir, I think from alcohol without rearrangement, I think this topic is also not there.
In which position?
Sir, in first position.
No, it's not in at the first position. I am just asking you about the second case. Like HCl and ZnCl2 is there. Just tell me that if I am having HCl and ZnCl2, where at which position my Cl will gonna attached? Because this is the question that will gonna be asked in your exam. Definitely. It's a very good
So
question.
third, third,
Hmm?
third, third on third will.
Third position. Okay.
Yes,
So you are saying that this will be my product. Fine.
yes, sir.
Okay. Tayyaba, are you agree with Hadia?
Yes,
Okay, fine. So, can you tell me, okay, fine. So, can you tell me about the first case where my CL will gonna be attached?
So my Cl will be attached in third.
In the first as well.
No, sir,
Same.
in the third position, like.
Third position is this now. I have attached at the third position. I'm asking you about SOCl2, thionyl chloride. What will happen? Where my Cl gonna be attached? It's very simple. Like I am saying you that we are not going to rearrange this. So if I am saying that we are not going to rearrange, that means from where this OH will substitute it, the Cl will gonna be there. Like remove this H. Like I am writing here, remove H. Sorry, remove OH. Remove OH. Remove OH with Cl. Simple, simple. With Cl. This is Cl. Okay. Just remove your OH with your Cl. That's it. This is the thing that you need to done here. Very simple. Here my OH is there. Just remove this with your Cl. So, you know, both the cases are the properties will come under the property of my alcohol. But this is also simultaneously a method of preparation of my alkyl halide. So if you see that here, this is my 2-degree halide. Fine, alkyl halide. You can say that
Yes, sir.
alkyl halide, or you can say that haloalkane. Okay, halide. And if you see here, this is my 3-degree alkyl halide, 3-degree halide. Fine. So if I ask you that I want to form 3-degree alkyl halide, which reagent I need to take? So definitely you will tell me that HCl with ZnCl2 you should take in order to form the 3-degree halide. If you want to form the 2-degree halide, you will take this. So using the different your reagents, you will get the different products. Fine.
Yes, sir. Yes,
Are you
sir.
getting my point? What I am trying to say.
Yes, sir.
So this is the thing. Okay. So there is another thing. There are some byproducts are also there. So if you perform this reaction, if you perform so once again. So if you perform this reaction, what will happen? If you perform the react this alcohol with the thionyl chloride, RCl will form with your SO2 gas and HCl gas. What? SO2 gas and HCl gas, and this is considered to be the best. This is considered to be the best method of preparation of alcohol. This question will gonna be asked in your examination most probably. This is the best method. This is the best method of preparation. Preparation. The best method of preparation of alkyl halide, or you can say
Yes.
that haloalkane. Why it is the best method of preparation? Because I'll tell you that because these are two gases. These are in the gaseous form. So if you see that if I perform this reaction, my byproducts will be escaped out in the form of the gases, and I am just left with my alcohol. Sorry, just left with my alkyl halide. Just I am left with my alkyl halide, and the other byproducts are escaped out in the form of my gases. So this is the best thing. I'll just get my pure form, pure alkyl halide. Are you getting my point?
Yes, sir. Yes, sir.
But if you see in this reaction, there is a byproduct that will be formed, which is your H2O. Why I'm saying that? Because if you see the mechanism of this reaction, what will happen? Initially, if I react this thing, the first thing will be my protonation, like this. This thing will happen. This protonation will happen here. So if the protonation will happen, see my this thing will be formed. O positive H2 will form, and this is the best leaving group. This will leaves out, and this thing will form. So if you see that here hydride shift will takes place, and after doing the hydride shift, you will form your 3-degree cation. Then your Cl minus will attack on this. Cl minus will attack, and this thing will form. So this is the thing. This is the procedure. This is the procedure of this reaction. And if you see that here, my H2O as my byproduct will be formed. And this H2O will be in the liquid form. So here, this thing, this alkyl halide is mixed with the water. So you are not gonna get this, you get your alkyl halide as in your purest form. If you want this in the purest form, you need to boil this thing. You need to boil at 100-degree temperature so that this water will be evaporated out. So, but in this case, you didn't do anything. You just react this thing. You just perform this reaction, and the other byproducts will be escaped out in the form of in the gases. So this is the best method. That's why it is the best method. Getting my point?
Yes, sir.
So can I move forward?
Yes, sir.
So the next reaction will be my reaction with. I am preparing what I'm doing. I'm preparing my alkyl halide. Okay. So the reaction with my P your my PX3 और हम कह सकते हैं रेड फॉस्फोरस प्लस H HX yeah HX or X2 no it's not HX it will be X2.
Yes, sir.
So this will be this will be the same thing. Like if you take this or this, both will be same. This red phosphorus will react with this gas and you will form PX3. So these are the same things. If whether it will be given to you, if whether the reagent will be this or this, both the reagents are the same thing. Fine. So
Yes, sir.
if you see that I'm having my alcohol, and if I took this thing, what will happen? Just simply do your work. Like just remove your OH with your X. Remove your OH. I'm writing this. Remove OH with X. Simple. What you need to do? Just remove your OH with your X. That's it. Simple. No rearrangement is there. No rearrangement. Fine. Where
Yes.
the rearrangement is there? I have told you that. In the first reaction, the rearrangement is there. After that, there is no rearrangement. Okay, fine.
Yes.
And what are the byproducts? So if you need to learn, if you want to learn the byproduct, so there's a trick. The trick will be that if 3 is there, write the OH 3 times, like ROH 3 times because PX3 is there. So this is a trick. This is not the logic. There is nothing
Yes,
logic
sir.
here. Hai. This is just a simple trick in order to learn the byproducts. So write this P as this, like PX3 as this, and remove this like this. Remove like this. What you will get? You will get 3 RX plus your H3PO. How much? PO 1, 2, 3. PO3. Fine, you will get this byproduct. Why I am telling you this trick? Because there is another reaction with which is very similar reaction with your PX5. So here 5
Yes.
is there and here 3 is there. So byproduct, you will face difficulty in the byproduct. That's why. And byproduct is not important to write. But if question ask you, if the examiners ask you about the byproduct, you need to know about this. So that's why I'll explain you. I'll give you the trick. So the simple thing is just remove the OH with your X. Simple. Just the simple thing. Like if you are having this, the same question, I'll give you PCl3. What you will do? Just remove your OH with your Cl. Simple. Very simple. Okay? Nothing new.
Yes.
The next thing will be your up. If you see that here is this is my byproduct. So this is not the you will not gonna see this in a pure form because this is not gonna be escaped out. है. But that's why it is the best method. That's why the thionyl chloride is the best method of preparation. Fine. So the next one
Yes.
will be your XCl and the next one will be your PX5. Okay. So in PX5, my ROH is there. And if you react with PX5, what will happen? Again, the same thing. R X will form again. And what are the byproducts? Again, there is trick. The trick will be this, like this. This is the trick. There is no logic there. This is the trick, simple trick that you need to know. So write here px3 like this. Write px3 and how many x are left? 2x are left. Like I'm having 5x. So 3 I have used here. So how many are left? 2 are left. So write this as this. Fine. And break this. Break these bonds like this. So what you will get? You will get your Rx like this. This is the byproduct. This is the main product. And your this. This is your POX3. This is your byproduct. And HX. This is also your byproduct. So this is the trick. So how are you gonna remember if you are having 3 as there? So what you will do? You will write this ROH 3 times. I'll do this. And if 5 is there, so write this thing like this and just perform this. Fine.
Yes, sir. So, will they
Huh?
be asking any questions like if it's a reaction with PX5? So, will it be PX4?
I'll give you questions. When I'll complete all the reactions from your in the method of preparation, then I'll give you the questions. Now, collective. There are collective questions which will gonna be asked. Like single questions, there's very minute chances of asking these single questions. In the maximum chances where the single question will be asked, I have explained you like this here. These type of questions is there. Like here, this is the very good question, and you need to learn about this. And the question will comes up, explain the mechanism of your what if you react the halo acid with your alcohol. Explain the mechanism. Then you need to explain the mechanism by performing each and every step. Like by the first step will be the protonation, and the second, this is like you need to write that this reaction is composed of 2 steps. The first step will be the protonation, and the next step will be your attack of the nucleophile. Fine. And there is an intermediate state will be formed like this. And this intermediate state, if rearrangement is possible, then we need to do the rearrangement, and then after we gonna find the product. So this is the mechanism that can be asked, and this is the question that you need to know about. Then after this type of question, like which rate of reaction will be the faster, like this. Rate of reaction, on the basis of rate of reaction. This is the rate of reaction. Fine. This type of question definitely gonna be asked because it's a very simple question. 3 degree, 2 degree, 1 degree. On the basis of the hyperconjugation, we'll just gonna write the answer. And then after there, this is the test that will gonna be asked about which will be the faster, which will shows the faster ability. Hai. So that will also gonna be asked. So this is I also completed here. But and this type of question is also gonna be asked like HCl, HBr, HI is there. Which if I use HI, whether the reaction will be fast, or if I use the HBr, whether which will be the fast. They will ask you the reason why it is there, why it is this. The reason that the size of the anion will be the more, and if you go down the periodic table, the size will increase. So if you compare the size in the halogen series, the iodine will having the highest size, and because of the highest size of the iodine, the bond will be easily gonna be breakdown. And if the bond will easily gonna be breakdown, then the protonation will take place in a faster or a less interval of time. So this is the reason. I'm telling you the reason. Fine.
Yes, sir.
Okay. If anything, if you are not able to, understand, just ask me at that position. I'll definitely tell you. And if you thought that the this thing will never is not given in the NCRT, or it is out of the NCRT, you're definitely allowed to tell me on that point. Fine.
Yes, sir.
And
Sir,
but
is it
what is it?
this is the method of preparation of haloalkenes or haloarenes?
No, this is the method of preparation of haloalkenes. What is the difference between the haloalkane and the haloarene? In the haloarene, there is a benzene ring which is there. I'm not, reached at that uh, position. After completing the method of preparation, because in this class, I'll just complete the method of preparation of this. Then after in the next class, I'll do your chemical properties. And in the next class, means I have told you that I need 3 lectures in this. The one lecture
Yes, sir.
I'll took in the last class, and this is the second lecture, and the lecture after this, the reaction, this chapter will gonna complete in next 2 lectures. Fine.
So, did we
Yeah.
did the Flintstone reaction in haloalkenes
What
preparation?
can
So, did
you
we did the like in preparation of haloalkenes, there was a reaction Flintstone.
the what reaction? Finkelstein reaction, Schwartz reaction.
Yes, sir.
These reactions will come up, na. I have told you that I'll definitely cover each and everything. Just wait. And the next part, this is the reaction from the alcohol or the reaction from your pH3. I'm writing that. In the next slides, this will gonna be also there. And this thing will comes under the halogen exchange, because in the Finkelstein reaction, the halogen will gonna exchange there. In the Schwartz reaction or the Finkelstein reaction, if you see that, my alkyl halide is also present in my reactant side, but we are doing halogen exchange. Fine.
Yes. Yes, sir.
If you see that in the Finkelstein reaction, Ni in dry ether is there. Fine. So NaI in dry ether, what will happen? My Rx, if my RCl like this, if you're asking me, so RCl, if I react with Ni in dry ether, what will happen? This Cl will removed, and this RI will form. So what is this? This is Finkelstein reaction. My Cl will gonna be removed and my I will be gonna be substituted. So what is happening? Halogen is exchanging. This is also halogen. This is also halogen. So halogen, this will come under the halogen exchange. So I'll definitely cover this thing. Just wait. I'll definitely do this. Okay.
Yes, sir.
These are also there in the NCERT. These are also the most important things. Okay. So are you
Yes,
are you
sir.
able to get this?
Yes, sir. Yes, sir.
Fine. Okay. I'm giving you a very good question. So solve this.
Okay, sir.
Okay. Mm, okay, fine. So everything that I have uh, taught you, I'm asking question on this. Write the byproducts as well with uh, them, along with them. Okay. So
Yes,
five
sir.
reactions, PX3, PX5, say done. SOCl2 is done. HCl is done. Okay. Okay. Yeah, 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, there is another reaction which will be your NaVr or H2SO4. Okay, so this reaction I haven't give you this reaction reagent, but the reaction I have explained you about this. So if you this will be a good question. So use your mind and solve this. And I know that if just I'll tell you just one word and you'll definitely crack this question. But solve
Yes.
this and tell me the answer fast.
Okay, sir.
And if I'll tell you that the Finkelstein reaction and the Schwartz reaction, these are the reactions which is then the hydrocarbon. So if you able to know that, like if I teach you the hydrocarbon, then in that chapter
Yes, sir.
I'll explain this thing. Okay, but okay, in this chapter I'll also tell you about these things. But this is
Yes, sir.
part of the hydrocarbon, and this thing is
Yes, sir.
also coming up in this chapter. So this is the thing that I want to tell you, that this is the thing in this
Yes,
organic chemistry, everything will be there. This is the mixed thing.
yes, sir. So what is this NABR?
NaBr and H2SO4.
So it will go with HCl and ZnCl2.
HCl and ZnCl. Why HCl? Because Cl is not there. If you see, okay, I'll explain you. If you observe this, this is my what? If you see that this is my salt and this is my
Yes,
acid.
sir.
Fine, fine. So if you
Yes,
see
sir.
that this will form HBr. Together they will form HBr, like H the Na plus and Br minus like this, and H plus 2H plus and SO4 2 minus will like that. So this Na will go with this Na will go with SOCl2, and this will go with this. So if you see that HBr will form. Now solve this question. This is just the thing that if you're able to crack that, this will be the same thing. Now do the same thing that you have done with this HCl and ZnCl2. They got the concept correct, but there is a slight thing that you should consider.
So it will go with Na.
It will go with. So tell me, I'm solving this. So tell me where my HCl will comes up at which position? 1, 2, 3, 4. There are 4 positions. 1, 2, 3, 4. So in the first case, this is the first case where my Cl will attach. Adi adi above. Fast, very fast, because this question you have done very much number of
So
times.
in the first, like in the second, it will be
Why
added.
be the second? It will definitely be the third now. I'll explain you many times. See,
Yes, sir.
see this thing. This is the same question. Which is the third position? This is the rearrangement. In this thing, you need to do this. You shouldn't allow to solve this directly. This is not a direct question. You need to follow every step. That's why I have explained this each and every step in very detail. Why should I need to? In this case, I didn't explain you the detail because just you need to remove the OH and substitute with your Cl. That's it. But in this case, there is no thing which is if you do a slight mistake, you'll definitely got the wrong product that you are doing. Okay, so
Yes.
follow these steps. Follow the complete step. Now here, tell me where the Cl will attach. Fast, very fast. One, two,
So in the
three.
third.
Why in third? Here, no
They're in the
rearrangement.
second.
In second,
Oh yeah, right. Second.
yeah, no rearrangement is there. Now, this is the only case where you need to do the rearrangement. That's it. Then after, no need to do any rearrangement. No. See here. Tell me fast, fast.
Sir, over here it will line the first one.
Why first one? Again the second one. Same, remove, same thing. Remove OH with your Cl. Same thing. Here, same thing. Remove your OH with your Cl. Same thing. From where the OH is present, just put your Cl at that position. Simple, very simple. And this is the best method of preparation because my byproducts are SO2 and HCl. Here my byproducts are because it is HCl5. So byproduct are
Yes.
this. This is my byproduct, and here my byproduct will be my H3PO3. Fine, and here my byproduct is water. Now here what will happen? Again HBr is there, so H plus and Br minus. Again what will happen? Protonation. So follow each and every step. Each and every step follow. So if you do the protonation, here this thing will happen, and this
Yes,
is
sir.
the leaving group. This cation will form. Now do the hydride shift. If you do the hydride shift, I'll get my cationic position at the third degree, and then attack this Br to this positive sign, and you will get your this product, which is will be the same. HC the place where the Cl is there, there is the same place where the Br is attached. So this is the question. So it's a very good question. Fine.
Yes, sir.
So you need to revise this question. Revise each and every
Sir,
case. Huh?
sir, actually, this topic which you're explaining, sir, actually, this topic is also not there in our textbook. It's deleted.
It's not there in the NCRT. Confirm.
Yes, sir,
Which
it's not
topic?
there.
Which topic?
So this one only, like the process which is taking place,
This
there is no.
H plus and Br minus.
Yes, sir.
Okay, okay, okay. So see. In the NCRT, what is there? In the NCRT, your reaction with HCl and ZnCl2 is there. What is written there? Halogen acid is written there. And this is my halogen acid.
No, sir, we don't have halogen acid. We have halogen like exchange.
Okay, okay. Just give me 1 second. I'll tell you on which pages it is there. If you want to, read the NCRT. So you are not able to get the points, the details, or you can say that the concepts. In the organic chemistry, there are lots of concepts are there, which is hidden inside the lines. And if you didn't follow the concepts, you will do the same mistake that you are doing again, like this in the first part. So you need to know about this. So I'll tell you where it is there. Just give me 1 second. See, your again, if you go to the thing where the method of preparation is there, can you tell me which page number are you there? At which page number? Tell me
So
first.
I'm at page number 64 and 65.
Page number 64 and 65.
Yes, sir, it's the revised textbook.
Okay, revised textbook. So you are at the page number 64 and 65. What is the
Yes.
heading? Is it there a method of preparation of haloalkenes and haloarenes is there or not?
Yes, sir. First, sir, it is like different. First is methods of preparation of haloalkenes. Then
Huh,
all
so,
those topics are
so method of preparation of haloalkenes are there. Confirm? And that
there.
will
Yes, sir.
be from alcohol, starting from alcohols.
Yes,
Fine?
sir.
So
Yes, sir.
if you see there are some reactions which is written in between
Yes.
the paragraphs. How many
Yes,
reactions?
sir.
1, 2, 3, 4, 5, 6. There are 6 reactions are there.
Yes, sir.
Fine. So
Yes.
see second reaction
Second reaction, yes, sir.
and read that reaction. What is that?
So it is ROH plus NABR plus H2SO.
ROH plus NABR
NABR
plus,
H2SO4 give rise to.
and this is the same reaction. This will be the same reaction. See, what is the reagent? A reagent here. NABR with H2SO4 reacting with the alcohol, which is this. This is my alcohol. This is my R group. This is the R group. This is my R group. Aya.
Yes, sir.
Okay. So I know which is there and which is not, and which is important, which is not. Because if you want to know that the ring expansion or ring contraction is there or not, so ring contraction, I'll accept that it might be a chances that ring contraction will not be there, because the question will never gonna be asked from the ring contraction. So that's why I'll never gonna explain the ring contraction, but the thing will be the same. But if we talk about the ring expansion, then in the organic chemistry, if you move forward and if you complete the whole organic chemistry, when the question comes up to you in your final examination, the question will never gonna tell you that I'm from this chapter, I'm from that chapter. It will be a combined question of the organic chemistry that would having a reaction of your hydrocarbons also. Like you have told me about the Finkelstein reaction and your Swartz reaction, and that Finkelstein and the Swartz reaction are there in the hydrocarbon and the your hydrocarbon in class 11. But in your class 12, there is no such thing as there. But why they are asking? Because it's an organic chemistry. You have to know about these things. If you know about these things, you are able to solve questions
Yes,
conceptually.
sir.
But if you learn, like what is there in the NCRT, I'll tell you. In the NCRT, the question is ROH reacts with NABR with H2SO4, you will get what? You will get RBR. So how you know that where this BR is attached? Where is this
Yes.
BR will attach? Like in this question, if you see this question, not question, if you see the concept here, my ROH is there. And Manicalica, what I have written here, remove OH with X. So if you remove this OH with X, you will get this RX. Fine. But
Yes,
where
sir.
this X is attached, can you tell me which position? In this question, there are certain positions like 1, 2, 3, 4, 5. There are 5 positions, 5 carbon positions are there. So where I need to attach this X. So this thing I have this is the job of mine, that I have to tell you the concept where this X will attach, where not, what is the rearrangement, why we are doing that, what is the purpose. So from here, from this, like if you see that from here, I took you to the advanced level that I am explaining
Yes, sir.
from here. So if you see that, why I need to told you about this, why I need to teach you about this, because this is not there in the NCERT. Like I have explained you what is the basic structure of an organic chemistry reaction. In that reaction, there is an reagent, there is an reactant, there is a reagent, there is a solvent, there is catalyst, there is an intermediate state. How many intermediates? Three intermediate states, and we are discussing about this carbocation. But why in that HCl and ZnCl2, why we are doing this rearrangement? Because this reaction will proceed from the intermediate state, and the other reaction will proceed from the transition state. In that transition state, we do not need to do any rearrangement. This is the reason. And if you see that here, if you see that, what is this hyperconjugation? Why we are calculating this alpha H? Why it is required? That because it is not in the NCERT. If you what you are reading, this thing is given in the class 11th NCERT in your GOC, General Organic Chemistry. At that time, you I think learned about this hyperconjugation, inductive effect, resonance. What your aromaticity, mesomeric effect. There you have learned that, but now the time when I'll explain you about the haloarenes, like arenes, about the benzenes. Every reaction is already covered in the hydrocarbon, but I will explain you again because it is important to know the previous thing, and there are certain more additional things are there, but most of the things are the same. Are you getting my point?
Yes, yes, sir.
Yes, so this is what that's why I'll explaining you. So I am I'm leaving this topic ring expansion. Accept that because I am also feeling that from here there are very less chances of questions that will gonna be asked. Okay, so and if you see that I'm explaining you from the basic, from your orbital thing, like in your structure of atom periodic table, which is there in your class 11. From there, I'll taking up to that level because there are some fundamental chapters of the chemistry. If you know that there is a thing which is known as the foundation. If your foundation is weak, then it is very difficult to build up the concepts. So I need to build your initial concepts, initial foundation, like what is orbitals, then what is the subshells, and how many orbitals are there in a subshell. Like it is a building, it is the address, it is the location of the electrons where it is present, you know and from there then I'll took you to this thing, like I have drawn this now. So this is the shape, this is the dumbbell shape of my p orbital. This is how my p orbital will look like. So that's why I have made this, and that's why I'll explaining you all these things, like I'm having this thing,
Yes, sir.
this thing. So this is the that's why you are seeing that this is a very large thing and all, but it's a very smaller topic. But because of the previous things that are not clear, so that's why I'll explaining you more. Okay, so this is about my things. So just trust me. I'll teach you everything. I'll never gonna leave anything like which is there, which is
Yes.
very important to you. Okay, so
Yes.
this is the thing. Then after these are all reactions, and if you got your answer, na, this is there in the NCERT. Fine,
Yes, sir.
and it'll be in a written form, a text form, like the reaction form. This is there. Okay, so now
Yes.
the next thing will be my your reaction with the hydrocarbon. Now let's start from hydrocarbon. So this thing is already covered, but I'm explaining you again. And if you see the NCRT, I'm opening the NCRT again. So where it is there, So I am now teaching you from hydrocarbon 10.4.2. I didn't know about your NCRT page number because I am having the
Yes, sir, from hydrocarbons, like from
So
alkenes by
from
free
there,
radical
I'm going to,
halogens.
so this thing I'm going to teach you. Okay. So everything will be there. Fine. So from hydrocarbon. Okay. And this thing, the thing which is there in the hydrocarbon, na, everything is there in your class 11 thing. So I'm just repeating this thing. And if you learn these things, then it'll be very easy to you to catch up all these things again. Okay. So from the
Yes, sir.
hydrocarbon, so the first thing will be there is a reaction of RH. This is my RH. This is a hydrocarbon. This is the presentation of my hydrocarbon. And I'm reacting with X2. I'm reacting with X2 in presence of sunlight. This is the sunlight. H mu is the sunlight. Fine.
Yes, sir.
Now what will happen here? This H will remove and my X will be substituted here. But again, the most important thing is that there is a concept here in this reaction. There is also a thing which is the your mechanism. And where this mechanism is written, if you see that the first thing from alkanes by free radical halogenation. From alkane from free radical halogenation. So this is the concept. If you know that, what is this free radical? Very easy for you to understand. What is this free radical? C dot is my free radical. Okay.
Yes, sir.
What is C dot? Here, all these three valencies are, you know that the four valence electrons are there. Four valency of carbon. Carbon having four valency. The three valencies are filled up, but the one electron is left uh, untouched. Okay. So this is my free radical. This is my free radical. So this reaction will proceed from this mechanism, which is your free radical mechanism. So if it is written there, free radical, then I need to tell you about the free radical mechanism. But the mechanism is written in your hydrocarbon textbook, which is there in your class 11. So if you want, I'll explain you the mechanism. If you don't, I'll skip this. But in my opinion, I'll explain you the things which is the most important for you, and at least you should know about these things. Okay. So what will happen here? My H will remove from your X, but there's a question I'll give you. CH4 is there, fine. And what will happen if I react with your Cl2 in sunlight? What will happen? CH3Cl will form. Fine.
Yes, sir.
CH3 Cl will form. Again, I'm having this uh this is my hydrocarbon, and I'm reacting this hydrocarbon like this. So now the question comes up where my Cl will gonna be attached. Again, there are two questions I'm giving you, and these two questions are enough to explain each and every concepts like this, and both are having two different answers because
Yes.
there are different positions like this these are some different positions which is there. So where my chlorine will gonna attach? So this will based on the rate of reaction. This will based on the rate of the reactivity of Cl2 minus. So rate of the reactivity means that this is my 1 degree carbon. This is my 1 degree carbon. This is my 1 degree carbon. How many 1 degree carbons are there? Three 1 degree carbons are there. How
Yes.
many 2 degree carbons are there? This is the 2 degree carbon. How many 3 degree carbons are there? This is the 3 degree carbon. That means I am having how many 1 degree number of carbons? Primary carbons, that will be my 3 number. How many secondary number of carbons? Which will be the 1. How many tertiary number of carbons? Which will be the 1. Are you getting my point? What I am trying to say here?
Yes,
The
sir.
primary number of carbons will be the 3. 1, 1, 2, 3. Why it is primary? Because it is attached to one another carbon. If you see here, है so this, if it is 1 degree, because it is attached only with one carbon. See, if it is 1 degree, it is only attached with this one carbon. This is 1 degree because it is attached only with one carbon. Why it is 2 degree? Because it is attached to the third degree also. That's why it is 2 degree. And why it is 3 degree? Because it is attached to other three carbons. That's why it is 3 degree. Getting my point? So
Yes, sir.
this is the thing. But there is a thing which is known as rate of reactivity. And rate of reactivity means that at what rate this my 1 degree hydrogen will react. Like if I am having 1 degree hydrogen, then what is the rate of reacting of 1 degree hydrogen? What is the rate of reacting of 2 degree hydrogen? Or what is the rate of the reacting of 3 degree hydrogens? Because all these hydrogens are different hydrogens. Why? Because these hydrogens are attached to the different degree of hydrogen, different degree of carbons. So if these hydrogens are attached to different degrees of carbon, that means their reactivity will be different. That how fast they will react will be different. So the reactivity order will be 1 is to 3 is to 8 is to what? The 3 is to 8, and that will be, I'll explain, 5. 1 is to 3.8 is to 5. This is the reactivity order. And this is not there in the NCERT, but I am explaining you because I need to tell you the concept. If any question will ask from the question from your NCERT, you will easily answer them. This because if you see your NCERT example 10.3, there is an example questions are there. If you see that example question,
Yes, sir.
and identify all the possible monochloric structures, isomers. So if you see that, you didn't know about the isomers. What is this isomer? And this isomer is there in your class 11th.
Yes, sir. Yes, sir.
Fine. So I need to tell
Yes,
you
sir.
now what is isomer. Then you can find the answer. Huh?
So, like this number is like for
What?
the number you wrote, is it for what? Like
The number I have
written for what it
where?
is like? This
These
is
are
one
rate
one.
of reactivity. What we have done the experiment. And in that experiment, we have found that there is rate. Rate means this is the ratio. So this thing do not have any unit. Fine. Ratio means कि इसके कंपैरिजन में ये इतना तेज है, इसके कंपैरिजन में ये इतना फास्ट है. Like the reactivity order. Like if 1 degree carbon having a reactivity of 1, then the reactivity, the comparison of the reactivity of the other carbon, which is the second degree carbon, will be 3.8, and the reactivity of the third carbon in comparison to the other one will be 5. So it is 5 times more faster. Like from the 1 degree, my to 3 degree will be 5 times faster in order to react. Like it will react faster, at fast rate. This is the thing. Are you getting my point?
Yes, sir.
It is
Sir?
the order of reactivity. Yeah.
Yes, sir.
So
Sir, can
how
you
you
tell
gonna
me,
answer? Huh?
sir, can you tell us the difference between isomers and isomerism?
Isomers and isomerism.
Yes, sir.
Okay, I'll explain you when this thing will comes up. Okay, just give me 1 second, because if I leave this topic, then this will be the wrong thing now. Then I need to explain this again. So just give me
Okay, sir.
1 minute. I'll just complete this and I'll tell you. It's a very simple thing. Isomerism and isomer are very simple. Just give me one
Okay,
minute. I'll complete this and then I'll come to you. Okay. So
okay,
what you
sir.
need to do here, just you need to multiply this thing. Like how many primary hydrogens are there? 3. So 3 multiplied by 1. And here, how many secondary hydrogens are there? 1. So from what you need to multiply? 1 multiply 3.8. Again here.
Yes, sir.
The third thing will be 1 multiplied by 5 here. 1 minute. Yeah. 1 multiplied by, sorry. 1 multiplied by 5. So here, what we will get? 3. What you will get? You will get is 3.8. And here, what you will get? 5. So what is bigger? 5 is bigger. That means at tertiary position, where your 3 degrees. So listen me carefully. Please listen me
Yes,
carefully.
sir.
Where the 3 degree carbon is there, at that position you need to attach my chlorine. See here, my from R H is there. I am removing my H and I am placing my X. Where I am placing my H? The question comes up this, like where I need to attach my X. So at that position where the number will be maximum, where the number will be 5. If you compare 3, 3.8 and 5, which will be higher? 5 will be the higher. So what you need to do?
We
You
need.
need to attach the carbon at that position.
Yes, sir.
Getting my point? But
Yes, sir.
again, listen me. What I have written here. If you see that carefully, I am explaining you the reactivity of my carbon, not the reactivity of my hydrogen. not the reactivity of my carbon. These are the reactivity order of my hydrogen. So what mistake I have done here? The mistake is that I have multiplied the number of carbons, not the number of hydrogen. So if I am having 3 carbons, then how many hydrogens are attached? 1 degree hydrogens are how many? So if you see that 3 hydrogens are here, 3 hydrogens are here, 3 hydrogens are here. That means I am having 9 hydrogens, 9 1 degree hydrogens. And then I need to multiply this by 1. Are you getting my point? I have done
Yes,
this
sir.
mistake intentionally in order to tell you that you didn't need to do this type of mistake, where you need to attach that at that position where the to multiply this reactivity with the number of hydrogens, not the carbon. So here 2 degree carbon is 1. So how many hydrogens are here? 2, because the 2 valencies are filled up with the other hydrogens, with the other carbons, and the 2 valencies are left, which will be filled with the hydrogen. So 2 multiply by 3.8. And again, here there is 3 degree, only 1 carbon is here. And if you see here, multiply this by 1, multiply by 5, because only 1 hydrogen is there. So if you see that 9, and if you see here 6, 16, and again 6, 7.6, and if you see here it is 5. So if you see that, if you see the reactivity order, 9 is the maximum. So where my chlorine will gonna attach? My chlorine will gonna attach at the primary position, here or here or here. All these things will be the same. So how many chlorine will form? This thing and this thing. Why all
Yes.
these things? So you are asking me about what is the difference between the isomerism and the isomer. Now I'll tell you what is the difference between the isomer and the isomerism. So if you see that, if you see that, where 1, 2, 3, 4. There, this is the numbering of my this compound. If I number this 1, 2, oh sorry, 1, 2, 3, 4, like this. Just 1 second. This is the numbering. है ना? If you see that, my methyl is attached at the third position here. And if you see in this position, my methyl is attached at the second position. So these two are different compounds. And because the position, see, mark my words, because the positions are different, of the substituents, that's why it is my isomer.
Yes,
because
sir.
because my position, it is specifically, if I'll go more deep into it, it is a structural isomer, because it is a change in the structure, and in that structural isomer it is a part of position isomer, because the position of my methyl is different. Because in this thing, in this compound A, my position of my methyl will be at third, and if you see here, the position of my methyl will be at the second. So it is my positional isomer in the structural isomer. So there is a isomer. There is a thing which is not, okay. I'll explain you about the isomerism. So isomerism. What is isomerism? Just 1 second. Isomerism. So if you see that, what is isomerism? Isomerism is nothing but a same formula, same molecular formula, but different
Different structures.
structures and the orientations. Different structure, different structure, and your orientation in the space. So if you see that, I am having a molecular formula. What if you see this? If you see this, how many carbons are there? 1, 2, 3, 4. How many carbons? 4 carbons are there. Okay. And 5. If you see that 1, 2, 3, 4, and 5 carbons are here. So if I need to write 5 carbons are here. And if I need to know the number of hydrogens are here, so 3, 3, and 2. How many? 3 and 3, 6, 7, 8. And if you see that here 3 is also here. So 8 plus 3 is 11. But one hydrogen will be less in this case because one hydrogen is removed from the chlorine. So it will be your 10 hydrogen. How many hydrogens are here? 10 hydrogens are here. And how many chlorine? One chlorine is. So if you see that both structure having the same formula. See, one, two, three, four, five. Five hydrogens are here. Oh, sorry, five chlorine, five carbons are here. Again, five
Yes,
carbons.
sir.
If you count the number of hydrogens, the 10 hydrogens are there. If you count the number of chlorine, one chlorine is there. So both the cases, if I write the molecular formula, you are never gonna tell me that what is the structure in the space of this compound, because the compound having the same molecular formula will be different, will shows the different properties, different chemical properties, different your physical properties. They both show the different properties, but how they show the different properties, because in the different in their structure or the orientation in the space. Getting my point?
Yes,
Yes,
sir.
sir.
They show different properties. So that's why what is my isomer? If I compare this thing, like if I'm compare this thing, these two, A and B, this is A and this is B. These are my isomer. But what is isomerism? The effect. This is the effect. This is the isomerism. This thing, this phenomenon, like the change in the property based on the different structure or the different orientation. This phenomena is my isomerism. But these two structures are my isomer with each another. Like in this chapter, there is a thing which is known as enantiomers. Enantiomers are there. This will gonna come in your upcoming classes. Getting my point?
Yes, sir.
Yes, sir.
Okay. So this is what isomerism. Isomerism is, or I'll also explain you more about the isomerism when I'll teach you about the optical isomerism, because in this class you are having an optical isomerism as your topic. And this optical isomerism I'll explain you after completing this chapter, which is your haloalkenes and haloarenes. Okay, matlab after biomolecules, because I'm having some order na, that you told me about that. So then after I'll explain you the optical isomerism. In that optical isomerism, if you want to know about complete things about the isomerism, I'll explain you complete isomerism chapter, which is there in your class 11th and your class 12th. Also because the structural isomerism is also gonna be asked in your syllabus. But if you want that, I just need to know about things which is just important for me, and which the limited things, then I'll explain you the limited things which is important for you in order to know about the structural thing. So I'll explain you the thing which is important just. Okay.
Okay, sir.
So if you see that in this question, what is asked here? Structural isomers is asked, and the structural isomers are the part of the class 11. And if you see
Yes,
that
sir.
this whole topic from hydrocarbon is not a part of this chapter. It is there in this chapter. I accept that it is there, but everything is explained in your class 11 textbook. If you open that class 11 NCERT, you will see that everything is there. And if you read that, there it might be a chances that they have written that, like if you see that in the last line, unit 13 class 11th, see, before the example.
Yes, sir. It's in the addition of halogens, right?
Ha, see that here. So with which is the last line, like which are colorless, and unit 13 class 11, it is written there.
Yes, sir. Which are colorless. Yes, sir.
So yes. So this is the thing. All these things are there in the class 11. So the NCERT is also telling you that you need to go and refer those topics. That's why I'll explaining you each and everything. Okay, understood?
Yes,
Yes,
sir.
sir.
Okay. So if anything you are not able to, you know, understand, just ask me. We are done with your today's topic, and we'll move faster rate in the next upcoming classes. Okay, because we are going slower.
Yes,
Okay.
sir.
Yeah. Anything you need to ask me?
Um,
If anything, I'll
So,
explain.
like,
Huh.
if like, will they like in exams they'll be asking us to write reactions and all those stuff.
So you okay, you need to know about the exam, the type of questions that they will ask, no?
Yes, sir.
Okay, so the types of the questions that will ask is already there in your NCERT. Just practice the questions which is there in the NCERT. That's it. Like how many chapters I have completed like the first chapter solution. And the second chapter
The
is
three chapters.
3 chapters. Can you tell me the 3 chapters? First is the solutions. Second is the electrochemistry.
Electrochemistry and
And the third
chemical
one is,
factors.
going on. Na?
Yes, sir. This is.
Okay. So what you need to do, just you need to go to the NCRT index questions, examples, and your NCRT back and exercise question. That's it. Never gonna be, and the questions that I have, given you in your class, like in your physical chemistry, I have given you very questions, hai na? Very
Yes,
large
sir.
quantity of questions, hai na? So these are very important questions. Just do solve these questions, na? Practice these questions, and this type of questions will gonna be asked. And except that,
So
nothing
even
gonna be
those
there.
example questions also, right? This example
Example
6.5.
questions, in-text questions. There is in-text questions is there, example questions is there, and the back end exercise questions. That's it. That's it. Complete thing. And if anything is required external from this, I'll definitely give you, because there are lots of questions which I give you in the class are the questions that will be asked in the board examinations. And these are the PYQs also. They are the combination of the PYQs and the exemplar questions, which are important for you. So I have integrated all these questions in my notes. Okay,
Yes, sir.
fine. Anything else?
Sir, isomers can be considered as like in the different way of stereoisomers, right?
Are what what?
Isomers like
Huh?
have a second name, right? Stereoisomers.
Huh. Okay. See, isomer is basically a complete thing. And in that isomer, we have a classification of the structural isomer and your optical isomer. And there is another thing, conformational isomer and conformal isomer. So there are lots of isomers are there. And in the structural isomer, so if you see in the structural isomer, there are 5 and 6 different type of isomer are there. Like if you see that tautomerism, and if you see ring isomer, ring chain isomer, positional isomer, chain isomer. So these are different type of isomer under the structural isomer. And if you go to the stereoisomer, there is a optical isomer. And that optical isomer is a part of your class 12 NCRT. See? So that will I'll explain you the stereoisomer. These are the classifications of the isomer based on the change in the structure or the orientation. Orientation is the thing, orientation means that if you see, okay, I'll explain you about the orientation. If you see, this is my OH, this is my CH2OH, okay, and this is my OH, this is my H, this is my H, this is my OH. So this is a compound, okay, fine. So this is one type of compound. But if I change the orientation, how orientation? Like this, OH, H, H, OH, H, CH2OH. So if you see that at the first position, this is the first position, this is the first carbon, this is the second carbon, this is the third carbon. So if you see that at the first position, I change the position of this OH from your right side to the left side. See, this is the right side and this is the left side. So if you see that I have changed the orientation of my OH. So on changing the orientation, I'll also give different properties. Getting my point?
Yes, sir.
So this is the change in the orientation. So this will comes under the stereoisomer. Then
So
that will
this like changing of hydrogens here and there is there in biomolecules, right?
this is there in the biomolecules, correct? Confirm. Yeah. So I'll explain you everything in if the time comes up, then I'll explain you everything about this. Just trust on me. I'll definitely
Okay,
do
sir.
everything. Okay. Anything else?
Okay, sir. No, sir. That's
Okay.
it.
Are you enjoying that understanding?